Here's an introduction to math fundamentals to accompany algebra-based introductory astronomy. So in this class, we're basically just using algebra, and it's not really advanced algebra, it's just kind of run-of-the-mill algebra. And you may have had this in the past, but maybe it's been the distant past, and so you could use a refresher. So this is just a few slides on reminding you how some things are done. So commonly, it's sort of thing we need to do in solving astronomy problems is, solve for some variable. We'll call it x. And let's just work through some examples to show you how to do that. So for instance, we might have an equation that something, we'll call it y is equal to a times x, right? And we know what y is and we know what a is, and we want to figure out what x is. We want to solve for x. So in algebra, what we can do is we can take something that is in the numerator on one side of an equation, and we can move it to the denominator on the other side of the equation. So our equation y is equal to a times x that we started out with, you can take that a and divide it over to this side of the equation. You can move it over here in the denominator. And so this becomes y over a equals x, and then we know we've solved for x. So let's go ahead and go to another example. What if we start out with y is equal to a over x? Well, again, we can do the same sort of thing. We can move things from the denominator on one side of the equation to the numerator on the other. So what happens is we can take our x, we can move it over to this side of the equation. So we now have y times x is equal to a. We still want to solve for x. So what we have to do then is we have to divide y over, move y over to the other side, move it to the denominator, and we have x is equal to a over y. And then you've solved for x. So let's do one more example. So this one's slightly more complicated. We want to solve for x. We have an equation that y is equal to a times x squared. Okay, so first we're going to apply the same manipulation that we did. So we need to divide a over to the other side. So we now have y over a is equal to x squared. But we don't want x squared, we want x. So we have to undo, this exponent. So the way that we undo that exponent is we take a root. And in this class, we're typically just going to have the exponent's going to be 0, 1, or 2. So when it's 2, we use a square root. And so all we're going to do is take the square root of both sides of this equation. And when we do that, the square root cancels the 2 in the exponent, and you get that x is equal to the square root of y over a. And you've solved for x. So building on this algebra, we need to work with exponents, which is in itself just algebra as well. But I want to address it separately because it's something that we're going to use a lot. So it's important to understand it. So we can have positive numbers in the exponent, and we can have negative numbers in the exponent. When you have a positive number in the exponent, that means that the number is multiplied by itself some number of times, and that number of times is what the exponent represents. So for example, if I have x squared, x to the 2, that just means I have two x's, so x times x. Or if I put some real numbers in here, let's say I have 10 squared, or 10 to the 2, so we might say that. That means I have 10 times 10, which is 100. As an aside here, note that sometimes in lectures I'll talk about an order of magnitude. That just means a factor of 10. So 100 is 2 orders of magnitude larger than 1. And occasionally, oftentimes actually, I'll use this in a kind of a loose way. So I might have, instead of 101, I might have 203. And I'll say that 200 is 2 orders of magnitude larger than 3. It's not exactly a factor of 100, but it's close. And so we use that terminology a lot in astronomy. Now back to exponents, when we have a negative number in the exponent, it's very similar meaning to the positive exponent, but the numbers are actually in the denominator. So x to the minus 2, this means 1 over x squared, which is 1 over x times x. Or if I have 10 to the minus 2, that means 1 over 10 to the 2. So 1 over 10 times 10, which is 1 over 100, which is 0.01. When we multiply numbers, we add the exponents. So for example, if I have 10 to the a times 10 to the b, this is equal to 10 to the a plus b. Or for a more concrete example that we often use with scientific notation, if I have a number that's 2 times 10 to the 2, so this is another way to write 200, I multiply that by 3 times 10 to the minus 1, this is another way to write 0.3, then I multiply the numbers out front of the x here, of this is a multiplication sign. I multiply the numbers out front, so I get 2 times 3, and I add the exponents. I add 2 to minus 1. So 2 times 10 to the 2 times 3 times 10 to the minus 1, this is equal to 2 times 3 times 10 to the 2 minus 1. Okay, and 2 minus 1 is 1. So the exponent becomes 1. 2 times 3 is known to its friends as 6. So this is 6 times 10 to the 1, which is then 6 times 10, which is equal to 60. And if you're not comfortable with scientific notation, note that this is also addressed in the Intro to Astronomy lecture, so you get some more practice there. When you divide numbers, you subtract the exponents. So for instance, if I now have 10 to the a divided by 10 to the b, then this becomes 10 to the a minus b, because b is in the denominator, so it's actually a negative exponent if you put it in the numerator. If I take my scientific notation example, but instead of multiplying, I divide, I do 2 times 10 to the 2 divided by 3 times 10 to the minus 1, then this becomes 2 divided by 3 times 10 to the 2 minus negative 1. Now minus negative 1, the minus signs cancel, so I get 2 plus 1, so then I get 2 over 3 is roughly 0.667, it's close enough, times 10 to the 3. Right? Because 2 minus negative 1 is 2 plus 1, which is 3. And then again, what does this exponent mean? It means I have 3 tens, so 0.667 times 10 times 10 times 10, which is equal to 667. Now, one final thing that isn't a math tip really, it's more of a problem-solving tip, but it kind of fits along with the rest of this, is you really should use units as a tool to check your answer. So making sure that your answer has the right unit is one way to check that you got the algebra right. It doesn't guarantee that you got it right, but if your units are wrong, you know you made a mistake. So it's one way you can try to figure out where things went wrong. So just as a basic example, let's say we have a car and we know that it takes 2 hours to travel 60 miles, and we want to know how fast its average speed was. So if we use the right equation, then the correct equation here is that speed is your distance traveled divided by your elapsed time. So our distance traveled is 60 miles. It took 2 hours to do this. So 60, we have 60 divided by 2, and then our units, we can do algebra with the units. So we have mile per hour. So 60 divided by 2 is just 30, so we get our speed is 30 mile per hour, which we more commonly say is miles per hour. And that's a unit that you know, right? 30 miles per hour, that's something that you're familiar with. And it's also a pretty reasonable speed for a car to travel. It's a bit slow to go for a 2-hour trip, but it's at least reasonable. So this makes sense then, right? It doesn't guarantee you got it right, but at least you got a reasonable answer. Now let's say you accidentally, for some reason, you accidentally used the equation, the wrong equation, speed is distance traveled times elapsed time, right? Which is incorrect. But let's just say you used it. If you only crunch the numbers, you may not know you went wrong. But if you keep the units, you figure out that you'd get 120 mile times hour, right? Because instead of 60 divided by 2, you'd get 60 times 2. Instead of mile divided by hour, you'd get mile times hour. And so you get something that doesn't really make sense here, right? So 120 miles per hour would already be kind of fast, but not necessarily crazy. But when you see in the end that your answer is mile times hour, that's not a unit for speed. And so that some kind of mistake happened, and you can go back and try again and figure out where you went wrong. And that is it for this Introduction to Math Fundamentals for Astronomy 1000.